We are going to discuss answers to midterm number 2. The first question had to do with ads on NBA uniforms, and the question was, what are the implications of this approach? Of course, the idea is to improve consumer perception and therefore utility for certain products. So it is tied to the consumer utility concept. And to see that, here we have a model. On the horizontal axis we are measuring quantity of goods or services consumed, and vertical axis we are tracking the impact on the satisfaction or utility drawn. Original the utility function is drawn here. This suggests that at different levels of consumption, of course, if you consume zero, it produces zero utility, but as you consume more units, then utility drawn from it will increase, but of course at a diminishing return rate, which is the essence of the law of diminishing marginal utility. And should the advertisement campaign to be successful, then every level of consumption will generate higher level of utility, and therefore utility function shifts up. In the context of the market model, you have quantity and the price for an advertised product. You have a supply curve for this product, and then an initial demand curve pre-advertisement, and this would be the equilibrium price and quantity. Should the ad campaign to be successful through the uniforms of NBA players, then the demand curve will shift to the right and hopefully become less price sensitive as consumers become more attached and loyal to the product, and therefore more sales at hopefully down the road at higher prices. That's the question number 1. Question number 2 is the impact of labor productivity slowdown on profitability. In this context, you can start looking at the input-output model, on which you track the variable input such as labor on the horizontal axis, and then output or its contribution to the production on the vertical axis, and you have originally this production function, and shows that at certain level of labor input, the output is of a certain level. Should productivity decline, same number of headcount will produce less, and so this is true everywhere throughout this model, and therefore the production function shifts downward, reflecting lower level of productivity. You can now switch to the cost model, in which we look at the production of output on the horizontal axis and average cost on the vertical axis. And originally this is the cost structure associated with original production function. Should the productivity decline, that contributes to higher cost structure. So every level of production will have a higher cost. So this, let's say output as the Q star, this is average cost before, and this would be average cost after. And continuing this conversation in the context of market model, this is we measure the output on the horizontal axis and price of the product on the vertical axis. There's a demand obviously for the product, and there's a supply. Should labor productivity decline, pushing the cost up, that translates into a left shift in the supply curve, meaning that at every level of output, price has to be set higher to recover the cost. So as a result, you end up with lower sales, and what is eventually purchased by consumers will have to be priced higher to recover the cost. That was question number 2. Question number 3 suggests ways to improve labor productivity. One is through training and education, skill building that many organizations attempt. Another way would be to add more tools or better tools to labor. And therefore workers would be more productive. Imagine a carpenter with a hand saw as opposed to a carpenter with a power saw. Obviously, productivity will improve significantly. And finally, through motivation, financial, workplace respect, worker participation in decision making, etc., etc. All of these can improve productivity and therefore, in fact, can push the production function up as a result. So one or a combination of these three ideas can produce the outcome. Question number 4 was about the elasticity determination, and so question number 4, the story is that a patron of a bar at $4 price consumed 20 beers per week, let's say, and then the price, I'm sorry, at $3, and then at $4 he reduced the consumption to 16, and the question is, what is the elasticity, price elasticity of demand? So the definition of elasticity of demand, price elasticity, is percentage change in quantity demanded of, let's say, beer as a result of some percentage change in price of same beer. And now the question is, how do you calculate the percentage change? Calculation of percentage change. You usually have initial number x1 and subsequent number x2. To calculate the percentage change, the formula is x2 minus x1 divided by x1 times 100. So in a case of percentage change in quantity, you have 16 minus 20 divided by 20 times 100. And in case of price change, this is change in quantity, percentage change, I'm sorry, percentage change in price. It was originally $4 and then went to I'm sorry, it was $3 and went to $4. So it's 4 minus 3 divided by 3 times 100. So I have calculated these numbers, and in the first instance, going from 20 to 16, the numbers for this, when you divide this number by this number, if once you calculate it, it will be always a negative number, so that's why we look at in absolute value is minus 0.6, but we don't care about the sign because it always will be negative number. So we look at an absolute value and is less than 1, and therefore in this case consumer shows price inelasticity. When the consumer cuts down to 12, then for the same price hike, the consumer cut down further, meaning went to 12 minus 20 divided by 20 times 100. And if you calculate this number and divide it by the same price hike, you end up with minus 1.2, but in absolute value we ignore the sign, is greater than 1, and therefore consumer shows, in this case, price elasticity. So if the consumer cut back to from 20 to 16, it still is considered to be price inelastic. But if the consumer showed more reaction by cutting 8 beer out of their weekly consumption, at that point the consumer is considered price sensitive, or the demand is elastic. That's the question number 4. And finally, last question, which was a table. I have actually produced this table. I'm going to share it with you. Here we have the number of labor, 0, 1, 2, 3 to 7. Wages, $100 per day. So if you hire 0 person, there is 0. This is not quite clear. I apologize. but you can follow. So one person is 100, two would be 200, and 7 people would be 700. Output, if you hire 0 person, you produce 0 output, but then output is given to be 0, 10, 24, 39, 52, 61, 66, and so forth. Now, the price is always $10, doesn't change. Marginal physical product is a rate of change in output as you add more headcount. So if you go from 0 to 1, your output goes from 0 to 10. And then if you hire another person, your output will grow by another 14. I'm sorry. I lost my own. I'm sorry. Okay. Here it is. From 0 to 10. So marginal physical product is between 0 and 1 is 10. Marginal physical product going from 10 to 24. Marginal physical product is 14. From 24 to 39 is 15, and 39 to 52 is 13, and so forth. As you can see, in the context of a production function, here is labor input and its output. When you have hired 1, 2, 3 workers, the output reaches 15. The marginal contribution, the last person, is 15 units, and after that, if you hire a 4th person, it drops to 13. So therefore, you peaked in terms of marginal contribution or marginal productive labor. 3 is the highest number that produces for the firm, and so the correct answer is for the point in which the labor productivity diminishes starts at when the labor hired is 3. And then after 3 workers, marginal physical product falls from 15 to 13. So that's the answer there. And then when you look at the next question, in order to maximize profit, how many workers will the firm hire? If you track profit, which is basically total revenue, profit is total revenue minus total cost. Total cost, of course, is the labor cost and jumps by $100 as you hire 1 more. Total revenue is price of the output times quantity produced. So therefore, at $10 a price, you have a profit of 100, 240, 390, 520, 610, 660, and 640. So if you take total revenue and subtract it from total cost, then you realize that when the profit in this case has been maximized at 120 when you have hired 4 workers. If the market price should jump to 12, so you generate another total revenue, this time output times not $10 but $12, so you get 120, 288, 468, 624, 732, 792, and 768. In this case, when you subtract the total cost, which was the cost of labor, from the total revenue, you end up with the last column, where you end up with a profit of 20, 88, 168, 224, 232, 192, and 68. So the profit is maximized at 232. In that case, you have hired 5 workers. And that concludes the discussion on the exam question for midterm number 2.